Today we're going to learn how to graph quadratic functions, but first we're focusing on doing it using a t-chart or a table. Let's get started with some basic definitions and then we'll get into the graphing quadratic functions. So far we have talked about graph lines. We also talked about exponential graphs. These are graphs that are kind of curvy like this. And then today is about quadratic function, which is the main big thing in Algebra 1. Quadratic functions are referred to as parabola. There are two forms of parabola. They are referred to as standard form and vertex form. So this is what we call your standard form. And then this one is the vertex form. For the next 2 weeks, we're going to focus mainly on standard form. So this is the form that we're going to mainly focus on. Great job. All right, so how do we graph a parabola that's written in standard form? It's actually very easy. We're going to make a table, and that's how we're going to begin to graph basically most functions. So here's our first problem right here, example number 1. Y equals to 2x squared. One of the things I want you to know is that the corresponding coefficient that goes with the quadratic functions. For example, in this particular one, the one that we're looking at here is basically, you can see that a is equal to 2. So those are the corresponding coefficient with the given quadratic function. So to graph, the first thing we're going to need to do is we need to make a table. So go over here. Go ahead and make a table. Now you get to pick the x values. So this is your x value and this is the corresponding y values going with the x values. So pick the x values. Ideally you want at least 5 x values. I'm going to pick 0 and then I'm going to pick a couple of numbers to the left of 0 and a couple of numbers to the right of 0. So let's pick -1 followed by -2, +1 and then +2. So use at least 5 values. Now for each x values that you have selected, we're going to go ahead and we're going to plug it into the function. So plug it into the x values here. So that's where the substitute will come into place. And remember, once you plug each of these values in there, you're going to square it first and then you're going to multiply it by the number 2 that's in front of the x squared. So here's y equals to 2. Remember, you're plugging -2 in there. So -2 goes in there. All right. Let's do that for the rest and then we'll evaluate each one separately. Y equals to 2. And then you know what goes in here, right? That should be -1 goes in there. Y equals to 2 times. Y equals to 2 times. Y equals to 2 times. Okay, so and then the number that goes in there are 0, 1, and 2. Now we're going to evaluate each one of those. And then that's going to give us the y value. Evaluating the first one, we have to square the -2 first, okay? And then we're going to multiply it by the 2 in the front. That's going to give us 4, and 4 times 2 is going to give us 8. This is going to give us 1, and 1 times 2 is going to give us 2. This is going to give us 0, right? And then 0 times 2 is 0. This is going to give us 1, and then 1 times 2 is going to give us 2. And then this is going to give us 4, and then 4 times 2 is going to give us 8. Awesome. So now we have our y values, and what we're going to do is we're going to plot these pairs. We should have a total of 5 pairs of points. So let's start with the first one. So that's -2 followed by 8. So go to our graph, -2 followed by 8. That's going to be this point right up here. The next point is going to be -1 followed by 2. So that would be this other point. The next point is going to be 0, 0. So here's where 0, 0 is. And then finally we got 1, 2, and 2. And then finally the last point in our table is 2, 8. So 2 and then finally 8. Now if you look at the dots that we plotted, it doesn't look like it falls on a straight line. In fact, it doesn't, right? It looks like the letter V actually, the letter V or kind of like the letter U, but it's actually a shape that we call parabola. All right, so what we're going to do is we're going to connect all these points. Let's go ahead and connect all these points, and if you do it correctly, then you should get a graph that looks like this. Notice that there are arrows on these graphs, which means that it will continue to go up forever. Let's go ahead and shift to the next question. And before we work on the next question, I want you to see the differences between example 1 and example 2. So the only main difference between 1 and 2 is basically the fact that it has a minus sign before the number 2. In the first question, we can kind of see that a is a positive number 2. In the second question, a is -2. So that's pretty much the main difference between example 1 and example 2. So how does that change the graph basically, right? So that minus sign, okay, we can take a shortcut once we study the minus sign. So what that minus sign does is we still need to make a t-chart, and you're still going to need to pick like these numbers that we've selected for our x values. But what that minus sign does is that minus sign is going to make all our y values right here negative, and that's all it does. So we don't have to really plug it back in here, but you could if you like, and you're going to see the trend that all the values just get flipped negative. But what we're going to do is we're going to go, oh, well, that negative is going to make the 8 now a negative 8. It makes a 2 a negative 2, right? And then the 0 is neither negative or positive. And then you have a negative 1. And then finally you have a negative 8, because that's the only thing that the negative does. It makes all those values, all the y values, negative. Okay, so we can take a shortcut without, writing out each expression. And then now we're just going to graph those values. So go to the graph, and we're going to start with this one first. Let's graph the negative 2, negative 8. So here's negative 2, and then down here is going to be negative 8, okay? The next one on our graph is negative 1 and negative 2. So negative 1 and negative 2. The next one on our graph is 0, 0. The next one on our graph is 1, negative 1. The last one on our graph is 2, negative 8. So 2, negative 8. Okay? And now we connect these dots. Then again, it looks like the letter V, which is the shape that we call parabola. So, they're both parabolas. And if we analyze example 1 and example 2, what we will notice is that they're very similar graph. The only difference is that the first one opens up and the second one opens down. So what changes the opening of these parabola is the fact that the a value, whether or not the a value is a positive number or a negative number. But just keep one thing in mind, that when you're graphing parabolas, you need to start by making a table for each one. Great job. All right, we're going to do 2 last examples here. So in example 3 and example 4, you will notice that they are very similar problems. The only thing that we're doing a little bit different here is one has a +1, the other one has a -1. So now we're starting to introduce the c value. Let me show you what I mean. Do you remember in the original, like when we first started this video 10 minutes ago, where we mentioned that we're only going to focus on the standard form? The first 2 examples focus on the letter A. Now we're actually going to focus on the letter C, okay? You might wonder, well, Mr. Nguyen, we haven't really talked about the letter B. The letter B is a case where we're going to talk about it tomorrow. So go ahead and go back to your example 3 and example 4. And then one of the things that I want you to be able to identify before you start is what is your A and what is your B. So A is a half, right? This is A. It is the number before x squared. And then your C is 1. Your C is the constant. The constant tends not to have any variable being multiplied to it. So we're going to make a table. So go over here and make a table like this. All right, and then very similar to what we did in example 1 and 2, we're going to start out by selecting 5 points. All right, once we have selected the 5 points, and you can always start with these 5 points, we're going to go ahead and plug them in. Okay, so we're going to go y equals to 1/2. I'm going to write down all the expressions, and then we're going to plug it in. Awesome. And now we're going to take each of these numbers and we simply plug them in here. Minus 2, minus 1, 0, 1, and 2. All right. And then we're going to evaluate. So when we evaluate, we have to make sure we follow our order of operation. First thing we do is we have to do our exponent. So when you square, you get 4, okay? And then you're going to take half of 4. Half of 4 is 2. And then finally, you get to add 1. So that's 3. So this is 3, okay? Great job. Square first, positive 1. Half times 1, which is going to be a half, okay? A half plus 1 is going to be 1.5. Square 0, that gives you 0. 0 times a half is 0, and then plus 1, that gives you 1. Square 1 is 1, times a half is a half, plus 1 is going to be 1.5. Square 2 is 4, times half of 4 is 2, plus 1, that gives you 3. So now we have our points, right? We're going to go ahead and plot those points. So just be careful. We have our point. So this is our point, right? Okay. Negative 2, 3. Negative 2, positive 3. Negative 1, 1.5. 0, 0. 1 and 1.5. 2 and 3. All right. Again, it kind of creates that V shape. So go ahead and connect all the dots. And that's the graph of our parabola for that particular problem. Okay. Great. Let's take a look at example number 4. Now we're going to analyze example number 4 a little bit before we actually graph example number 4. So if you look carefully, the difference between 3 and 4 is the fact that 3 has a plus 1 and 4 has a minus 1. I got to take one step back actually, guys. I did not plot the 0, 1 correctly. So let's go back and replot 0, 1. 0, 1 should have been right here. So 0, 1 is right here. Okay, so the graph looks like this. Okay. All right, so back to this problem. So the only difference between example 3 and example 4 is one has a plus 1. The second has a minus 1. So what does that do to the graph? So let's think about it, okay? When we did our order of operation here, we actually had to multiply, square first, multiply, and then we add the extra 1, okay? So when we're doing the same thing to example number 4, we still have to make our t-chart like this. We still have to we have to select these numbers, okay? But because we've done example 3, we can basically take a shortcut for example 4. What is the shortcut, you might wonder? Well, the shortcut is instead of adding 1 here, we're actually going to subtract 1. And that's basically what our shortcut is, okay? So we had, but you know what? It might be useful for us to just basically write it out like this. So I will write it out for you. Okay, so if we simplify this expression, then we will get 1, okay? If we simplify this expression, then we're going to get negative 0.5 If we simplify this expression, we're going to get -1. This is going to give us -0.5. And finally, this is going to bring us back to 1. Okay? So let's go ahead and plot these onto our graph. -2, 1. -1, -0.5. 0, -1. 1, -0.5. Finally, 2, also 1. Okay? And so connecting these dots, we get the graph of our parabola. So let's look at the graph of example 3 and example 4. And then you might notice that one graph started. So this is kind of like its starting point right here. One graph started at 0, 1 versus the other graph which starts at 0, -1. Now generally, parabola has what we refer to as a parent function. And a parent function tends to start at 0, 0. So it tends to start here, like that. Okay? What the +1 does, or what the C does to the graph, is the C moves the graph up C units. When we look at this graph, because C, as you can see, this is our parent function, right? Because C is a -1, what that does to the parent function is it shifts the graph down 1 unit. Great. So the last thing I want to do is I want to summarize everything we've done so far and maybe add in a few characteristics. So here's a few things we know. When the A value, which is the number before the x squared, right, is positive, the graph is going to open up. Okay? When the A value is negative, the graph is going to open down. And then we also talk about shifting the graph up or shifting the graph down. So when C is positive, the graph will shift up. And then when C is negative, the graph is shifted down. I'll see you guys in the next video.